Hello friends, again a very warm welcome to one and all present over there and listening to me. Right now we are here with some question which will be based on the JEE main pattern. We have covered the question which was based on CBSE pattern and the NEET pattern. Now it's time to just test our knowledge whether it is quite good for the JEE main or not. I have taught you the chapter thoroughly and I am hoping that you are clear with all those concepts that is important in the chapter. In the very last lecture where we have covered the NEET pattern question, I have told you that the one important thing in this chapter is the photoelectric equation. Again, you will see that in this pattern, the level of the question will be a little bit higher, but the concept, the approach, that will be same. So that means formula will be same, but we have to the question will be just a little bit twisted. We have to find that twist, we have to find the trick to solve that twist, and then we will be solving it. So without wasting much time, let us move towards the first question. Alright, so as I always say that, don't go over the length of the question. More lengthy the question is, more easy will it become. Now here I can see that from A to D there are options. The question is from here to here, from statement 1 to statement 2. So let us just see what is the question saying. Statement 1 says that when ultraviolet light is incident on a photocell, its stopping potential is V0 and the maximum kinetic energy of the photoelectrons is K max. Now they are saying that when the ultraviolet light is replaced by the X-rays, the main important line in this question is this: when the ultraviolet light is replaced by the X-rays. So they are asking what will be the both V0 and K max increase. According to them, this is the statement which is saying that on replacing the ultraviolet light by an X-ray, this V0, that means stopping potential, and the K max, that means the kinetic energy of the photons, will increase. Now let us just see whether this statement is true or false. According to them, the second statement is photoelectrons are emitted with the speeds ranging from 0 to a maximum value because of the range of frequencies present in the incident light. According to them, they have given us a statement and we have to show them whether this is true or false, because 4 options has been given. In that 4 options you can see statement 1 is true, statement 2 is true, statement 2 is the correct explanation of statement 1. These are 4 options and we have to take a one particular answer, right? Now I can say that I have to proceed this question with something that is E equals to h nu. In the case when I am changing the light ultraviolet to X-ray, I can say that the frequency of X-ray is higher than ultraviolet rays. So I can say that frequency of X-ray is higher than UV rays. Now if frequency is higher, that is quite obvious that energy would be higher because E equals to h nu. So we will say that energy of X-ray will be higher. In the question, let us just see what was the first statement. According to them, when the UV is replaced by X-ray, both V0 and K max increase. K max is what? The kinetic energy, the maximum kinetic energy. And we can see here, because the frequency is increasing, we can say that the kinetic energy is increasing. So finally, we can just write this energy as Ke max, That means it is been increasing. Now let us just see how can we show them that yes, whether the stopping potential is also getting affected or not. So let me just tell you, there is a relation between energy and stopping potential. First of all, what do we mean by stopping potential? It is that negative potential, that minimum potential at which the photocurrent stops. That means no photocurrent will flow, no photoelectric emission will take place at that stopping potential. So we can say that this is kinetic energy max. This is again photoelectric equation given by the Einstein. Ke max equals to h nu minus h nu naught. This is the work function. And we can write this kinetic energy as E into V naught. So if I talk about the stopping potential, I can write it as h nu by E minus h nu naught by E. Now you will see that because the kinetic energy is increasing, we have seen a relation that if the kinetic energy of the incident photon is high, so the number of photons, the frequency, you can say if the kinetic energy of the photon is higher, so that means photons will be getting emitted at a higher rate. And then you can say that because the photon is getting emitted with a higher rate, you need to apply more energy to stop them. So that means your stopping potential would be also high. So we can directly conclude from there, since kinetic energy is maximum, so stopping potential will be maximum. We have concluded these two things, and so we can say this statement is correct. Why? Because on changing the light from UV to X-ray, we have seen that both the stopping potential and the kinetic energy max has been increased. So this statement is correct. Now let us just see and ignore those options which are irrelevant for us. In the option 1, we can see statement 1 is true, statement 2 is true, statement 2 is the correct explanation of statement 1. So right now we are not aware for statement 2, so we will not touch this A option. While in the second case, I can see statement 1 is true, statement 2 is true. I know that statement 1 is true, but I don't know about the statement 2. So again, I will not touch this option. But in the C option, I can see statement 1 is false. So that means this option must be incorrect. I can totally ignore this option because I know that this statement is correct, right? Now, in this statement, in this option, statement 1 is true and statement 2 is false. I have ignored one option from my question. Now, let's see what is the statement 2. According to statement 2, the photoelectrons are emitted with the speed ranging from 0 to a maximum value. Yes, this is true that the photoelectrons emitted, they ranges from 0 to a maximum value. But the reason that has given because of the range of frequencies present in the incident light. This is not the correct reason, because we know that the photoelectrons emitting and ranging from 0 to a maximum value, this is happening because of the collision. Because at the time of collision, they lose their energy, and due to which this ranging from 0 to a maximum value. So we can say that statement 1 is true, but statement 2 is false. Because this is not the correct reason of this statement. This is not supporting this statement. So we can write statement 1 is true and statement 2 is false. So this is the correct answer, right? Now let us just move to the second question and see what is the second question saying. All right. So we are having something like a numerical with us. As I have told you that the level of question would be a little bit higher than NEET, but you are going to solve it very easily. And also I should tell you, this is a very scoring chapter, because in this only one or two things you have to remember. You have to focus on the graphs that has been drawn in the chapter, and you have to focus on the equations, photoelectric equation, formula for the work function, and formula for the stopping potential, the relation between wavelength and stopping potential. This all you should know. The relation between wavelength and kinetic energy, between momentum and wavelength. So this is such things, the basic things that you should know about this chapter. Then your way would be very much clear. You would be going very much smooth if you are knowing these basic things. So let us just see what is the second question. The surface of a metal is illuminated with the light of 400 nanometer. So let me just write, the wavelength has been given as 400 nanometer. And what else? The kinetic energy of the ejected photoelectrons was found to be 1.68 electron volt. So let me just write here, kinetic energy of the ejected photoelectron was 1.68 electron volt. Now what is the work function of the metal? We have to find this work function. Now you know that work function is what? The minimum energy that is required to eject the electron from the metal, right? Now we know the formula. The formula says kinetic energy of the emitted photoelectrons is h nu, that is the energy of the photons, minus the h nu naught. That means this is the work function. You can write it as phi naught, and we have to find this phi naught. Now in the question I have been given the lambda and I have been given 1.68 the kinetic energy. So let me just start with this. Just you can write the phi naught here because you have to find this. Also you can focus over one thing. Here in this question we have been given the value of Hc. So we are generally going to put this value. You can remember this value because multiplying this H with C is a constant term. H is constant, C is constant. So you can just remember this term, 1240 electron volt into nanometer. Now in this question we are having 1.68 equals to h nu. I can write this nu in the form of C by lambda minus work function. Now if I have to find the work function, now you can see how simple this question is. You just have to know about this equation and nothing else. How important this equation is. And you can score a very good marks if you are clear with this. So now let me just bring this phi naught to here because we have to find its value. It would be Hc by lambda minus 1.68. Now what you can see here, Hc, the value of Hc has been given, that is 1240 electron volt into nanometer. So let me just write this value, 1240 electron volt into nanometer divided by the wavelength. Wavelength is 400 nanometer. Now you have to subtract this by minus 1.68. This nanometer cancelled. Now I am having 1240 by 400 minus 1.68. Now you can solve it very easily, and whatever will be your answer coming, whatever will be the thing, whatever will be the number that will be coming out here, that will be your work function. I have just told you how to approach, how to proceed in this question, but the answer will be given by you. And whatever will be your number that will be coming here, let me just write again, that would be 124 by 40 minus 1.68. Just solve for this and find the value out. Use your calculations, use your calculators and bring out the value of this equation, right? So whatever will be your value, you just have to tick over here whichever is the correct option, right? And one more important thing, that your answer would not be as much correct, as much appropriate, you can say accurate. The correct term is accurate. Your answer would not be accurate, but whenever you will see that this option is very much approaching with my answer, you can just tick that one. So let me just suppose the answer is 1.68. Supposing I don't know what is the term that will come out. Suppose, okay, let me just say this is 3.09. So, and my answer is coming as 3.07. So please do not get bothered. 3.07 is closest approach of this option. So you just have to tick this one. Alright? Because these all are very much far away from your 3-point range, right? So this was your question number 2. Now let us just see what is the question number 3. Okay, so the question number 3 says that the photon of frequency nu has a momentum associated with it. If c is the velocity of light, what is the momentum? So let me just start the question. Photon of frequency nu has a momentum. We know that there is a relation between frequency and momentum, and that relation is nu equals to c by lambda. This is a relation between frequency and wavelength, and there is one more relation, lambda equals to h by p, relation between wavelength and momentum. Now let us just see what is the question says. The photon of frequency nu has a momentum associated with it. If c is the velocity of light, what is the momentum? We have to find out this momentum. That means p equals to h by lambda, right? And you know that lambda is, you can just find this lambda from this equation. Suppose this was equation number 1 and this is your equation number 2. Now find out the lambda from this equation. My lambda would be c by nu, right? So I have to just put this value over here, p equals to h by lambda, and lambda is c by nu. So your answer is p equals to h nu by c. Now let us just see whether there is any option in the question or not. The answer is h nu by c. Is there any option? Yes. So the option number D says h nu by c. So that means this is your correct answer, right? How simple this question was. I was telling you that the basic thing that you should know is these things. How to convert this frequency into wavelength. What is the relation between wavelength and momentum? These are just small things that you should know. And you can do the JEE main question C. Now the next question, and also I must tell you that these questions are the previous year questions and the sample paper questions just prepared for you, so that you can get prepared for the toughest exams, for the competitive exam. Because in this era, which is where you are surrounded by the number of competitors, you have to win out. You have to be a winner. To be the winner, you must have a deep knowledge of any subject. And a deep knowledge is obtained by just a little mind. You just have to focus on your syllabus only. Just pick out your NCERT. The NCERT is the core of your syllabus. If you are going to cover it thoroughly, I am pretty much sure that you are going to solve these such questions and you are going to crack any exam. But yes, definitely for cracking any exam, you just need practice. And for that practice, you need to consult more and more number of books, right? So now let us just move to the next question and see what is the next. All right. So the next question says that the threshold frequency for a metallic surface corresponds to an energy of 6.2 electron volt, and the stopping potential for a radiation incident on this surface is 5 volt. Now just see what are the two things that has been given. First of all, what you have to notice in this question is the threshold frequency for a metallic surface corresponds to the energy this. That means I can write this energy as H into nu naught equals to 6.2 electron volt, because threshold frequency is what? Nu naught, and this threshold frequency is corresponding to the energy this much. So I can write H nu naught equals to this. Now this must be more clear. Now okay, and the stopping potential for a radiation incident on this surface is 5 volt. So I can write this stopping potential as 5 volt. Stopping potential is written as V naught. So this is 5 volt. Now we have to find which is the radiation that is coming out, whether it is lying in ultraviolet region, visible region, infrared region, or the X-ray region. And to find this region, we should know the wavelength. So that means basically we have to find the wavelength. And how can we find the wavelength? We know that there is a relation, and the relation is kinetic energy equals to H nu naught minus H nu minus H nu naught. And this has been given that H nu naught is 6.2 electron volt. Now the something that is missing here is, alright, I can write this as E into V, and V is 5 volt. What I can start here with, just let me remove this and we will be starting it with H nu equals to 6.2 plus 5, because we know that H nu is what? H nu is nothing but the H nu naught plus E into V naught. How can I say this? I have just written that equation, that photoelectric equation, in just another manner, because EV naught is what? The kinetic energy. I had earlier written as kinetic energy equals to H nu minus H nu naught, or you can write it as kinetic energy can be written as E into V H nu minus H nu naught. So I have just written this equation into this form, that is H nu equals to H nu naught plus E V naught. Now I know that H nu equals to H nu naught, which is 6.2, plus E into V naught. Now E into V naught, I should tell you here one thing. I know the value of V naught. V naught is 5 volt. So I can just write this E as it is, because E is the electronic charge and V as 5, right? And this 6.2 is what? Let me just again write over here. This is in electron volt plus E into V naught. V naught is 5 volt. So that means unit has become same, EV into EV. So this is now H nu equals to 6.2 EV plus 5 EV. Electron volt, right? Now add these terms and you will be having 11.2 electron volt. Now the question has become very simpler for us. We have to find the value of this wavelength, and the wavelength formula for wavelength is C by nu equals to C by lambda. So lambda is C by nu, because we know that nu equals to C by lambda. So we can use this here, 11.2, and you will see that the value of lambda, this will be Hc upon 11.2. So put the value of Hc, 6.6 into 10 raised to the power minus 34 into 3 into 10 raised to the power 8. Now let me just see in the question whether this has been given the value of Hc or whether one particular value has been given or not. So no, I cannot see any such term out here. So that means this wavelength, if you solve it, you will see that this wavelength has come out to be in this range 1108.9, and if you will see, you can see that this range lies in the UV region. You must be aware of the electromagnetic spectrum. Don't forget to learn the electromagnetic spectrum when you will go for your exam. Basically, this is required for physics. Most important thing, you should be, this electromagnetic spectrum should be on your tips. So don't forget to remember to learn the electromagnetic spectrum table. Alright, because such questions can be found in your exam where you will be knowing this wavelength, you have found the wavelength, but you will not be knowing that in which range, in which region this wavelength is lying. So for that, this thing has been important. This becomes important that you would be knowing about the electromagnetic spectrum. Alright. Now we can tick over here that this answer is ultraviolet. Now let me just move towards the next question. And the next question says that the radiation corresponding to 3 to 2 transition of hydrogen atom falls on a metal surface to produce photoelectrons. Okay. And these electrons are made to enter a magnetic field of 3 into 10 raised to the power minus 4 Tesla. If the radius of the largest circular path followed by these electrons is 10 millimeter, what is the work function? First of all, the thing that has been given, transition. 3 energy level n equals to 3 to energy level n equals to 2. And during the transition, the photoelectrons are being emitted. These photoelectrons are then made to enter the magnetic field. And you know that when the photoelectrons will move towards the magnetic field, they will rotate in a circular path. And so they are telling us the radius of the largest circular path followed by these electrons. And this radius is 10 millimeter. What else has been given? Magnetic field. This has been given as 3 into 10 raised to the power minus 4 Tesla. What else has been given? The thing that has been given over here is n transition is taking from n equals to 3 to 2. Right. Now first of all, we will see what we have to find. We have to find the work function of the metal. That means we have to find the phi naught, or phi naught can be written as h into nu naught. We have to find this. Now how can we find this? There is one method, one or the other method to just proceed the question. And my method is based on one particular thing, and that is the photoelectric equation. I am going to proceed with that. And first of all, before going to that, I would like to tell you, you can see here one thing, that if the photoelectron is rotating in a circular path, there would be one thing, the centripetal force will be balancing the magnetic force. That means QVB will be equals to mv square by r. Now since these both are velocities, Q is charge, V is velocity, B is magnetic field. M is the mass, V is the velocity, R is the radius of the circle. So V and V getting cancelled, I am having mv equals to QBR. I have just found this thing now. Now let me see, they have told us this, but to find the work function, I will be using kinetic energy equals to h nu minus h nu naught, or you can write this as phi naught simply. To find the phi naught, we can have h nu minus kinetic energy. to finding the kinetic energy, or you can say this h nu, I can do one thing. Because I have been given this transition, so I will be finding the energy from here. So the energy that will be coming out is, we know that En equals to 13.6 into 1 by nf square minus 1 by ni square. Nf is the final orbit, Ni is the initial orbit. So our final orbit is 2 and initial was 3. So we will say that 13.6 into 1 by final is 2. So this will be 1 by 4 minus initial was 3. So square, that means 1 by 9. So we will be having 13.6 into 36, 9 minus 4. 5 by 36. You are having energy as this. Now from here what we can do is, we can find out the kinetic energy. We know that kinetic energy can be written as E into V. So first of all, I would like you all to just note it down, because this is a beautiful question and I would like you all to focus on the board till the time I will write this question. So before I proceed further, you just note it down and then I will be starting to find the kinetic energy, because we have find the energy with a very beautiful manner, right? So just note it down and then we will start.